everyone, good morning and welcome back to MedicoPharma Lecture once again. This is Sunil Kumar Shah and today I am going to start a series of lectures on Pharmaceutical Organic Chemistry-I. Okay, and this series of lectures belongs to the second BPharm students. Okay, so I will just introduce to the syllabus which we are going to cover in POC-I. POC-I means Pharmaceutical Organic Chemistry-I, right? So let's start. So the syllabus for pharmaceutical organic chemistry is divided into 5 different units. Okay, I will write the name of the units. Okay, so first unit is, that is unit 1, which is going to explain classification, then nomenclature of organic compounds, and also it is going to discuss about isomerism. Especially it is going to discuss about a structural isomerism. Okay, the second unit, which is here, is mainly focusing on alkanes. You know what is alkanes. Even though if you don't know, don't worry, we are going to discuss them in details in the later lecture or in respective lectures. Okay, so we are going to discuss about alkane and alkene, as well as we will discuss about dienes. Okay, we are going to discuss about conjugated dienes in our lecture. So this is second unit. Now coming to third unit. Okay, unit 3. In this unit 3 we are going to discuss about alkyl halides. Okay, and we are also going to discuss about alcohols. Okay, so this is all about unit 3. Now coming to unit 4. Okay, so if you see unit 4, this is going to discuss about carbonyl compounds. Okay, so what do you mean by carbonyl compounds? Carbonyl compounds. So what do you mean by carbonyl compounds? So carbonyl compounds are those compounds which contain carbonyl group. What is carbonyl group? C double bond O group, right? C double bond O group. Okay, so this group is called as carbonyl group, and you have seen this group in many structures or many organic compounds. They are generally called as aldehyde and ketones. So here we are going to discuss about what? Aldehyde and ketones. Okay, ketones. And the last unit, if you will see, the last unit is that is unit 5. We are going to discuss about here carboxylic acid, and it is also going to discuss about aliphatic amines. Right? So these 5 units, if you will study all, that is your pharmaceutical organic chemistry is completed. The portion for pharmaceutical organic chemistry is just these 5 units. Okay, so these all 5 units which you are seeing here, they are very interesting, and I will try to make it easy. Okay, and the style of my teaching will be mainly focusing on making you to understand rather than studying and remembering all those things. No, I don't like that. You have to understand the concept. If your concept is clear, if your concept is built up, then you can easily remember these things. Okay. Now we will start unit 1, that is classification, nomenclature and isomerism of organic compounds. Okay, but before that I want to give you some basic concept which is going to help you throughout the study of organic chemistry. Okay, so the first basic concept which I am going to give you is electronegativity. What it is? It is electronegativity. You might have studied these things in 10th, 11th, 12th. Okay, but we will discuss once again. So what is electronegativity? Okay, so electronegativity is the power, capacity or ability of an atom to pull the electron towards itself. Okay, so suppose this is an atom A which is going to make bond with atom B. Okay, now so there will be definitely a bonding electrons over here. So these electrons are called as what? Bonding electrons. Okay, let me write here, bonding electrons, right? Now if you will see here, this atom A, it is going to pull these electrons, which electron? Bonding electron towards itself with a certain capacity or certain ability or with certain strength. Similarly, B is also going to pull this bonding electron towards itself with certain ability or capacity. So this ability of pulling bonding electron towards itself is called as what? Is called as electronegativity. Understood? And the atoms which are going to pull those bonding electrons, they are called as electronegative atom. So here if you see, suppose this A is more powerful and it is going to pull this bonding electron towards itself slightly. Okay, so same thing, I am going to write A and B. Now the bonding electron is shifted slightly towards A, right? It means what? It means atom A is more electronegative than atom B. Understood? And atom B is less electronegative than atom A. So in our periodic table, there are certain atoms which are more electronegative and there are certain atoms which are less electronegative. Okay, so we will see the series of electronegative atoms. Okay, so the most strong atom is fluorine in terms of electronegativity. Then after this fluorine, there is oxygen. Okay, and then after this oxygen, there is nitrogen. After this nitrogen, there is sulfur, and after this sulfur, if you will see, there is halogens, that is chlorine, bromine, iodine, right? These three halogens. And after this, which one is there? Carbon. And if you will see, carbon is slightly more electronegative than hydrogen, not much. So sometimes we can consider the electronegative, whose electronegative, carbon and hydrogen electronegative, as same. Okay, that's why. So carbon electronegativity is slightly more than hydrogen or equal to hydrogen. So this is the electronegativity series of atoms. Okay. So hope you have understood this concept. Okay. So how you can define electronegativity? So electronegativity is the ability or capacity or power of an atom to pull the electron towards itself. Which electron? Bonding electron. Okay. The next basic concept which we are going to discuss is on polar bond. Okay. So what is polar bond? You might have heard about it multiple times. So it is same like your electronegativity. Okay. So suppose there is a bond between A and molecule B where A is more electronegative and B is less electronegative. So you know there is a bonding electron. What will happen? Since A is more electronegative, it will pull the bonding electron towards itself. As a result, you just see what is going to happen. These bonding electrons are slightly moved toward A. As a result, it will develop delta negative. This will develop delta positive. Right? So here two poles has been created. Now this type of bond where two poles are there, delta negative, delta positive, both poles are there, then that type of bond is called as what? Polar bond. So how we will define polar bond? So we can define polar bond as whenever there is a bond between less electronegative atom and more electronegative atom, as a result the bonding electron will move slightly toward more electronegative atom. As a result, delta negative and delta positive will develop on more electronegative atom and less electronegative atom respectively. Okay, so such type of bond is called as what? Polar bond. Okay, so I hope you have understood, right? Now the next concept is on dipole moment. The next concept is our dipole moment. This is also similar to this all those stuff. So what is dipole moment? So as I said, whenever there is a bond between more electronegative, less electronegative atom, bonding electrons will slightly move towards A, delta negative, delta positive will develop, and hence what will happen? There will be creation of two poles in same molecule, that is called as dipole, right? Di means two. What you can know? Di means what? Two. So two poles has been created in same molecule, that is called as what? Dipole, and the moment of dipole is called as what? Dipole moment. Understood? So I think you have understood what is dipole moment. Okay. And one more thing I want to add over here is dipole moment is, it is a vector quantity. It is a vector quantity. What do you mean by vector quantity? Vector quantity means that which have magnitude or certain value along with direction, that is called as what? Vector quantity. Okay. Now the next concept which we are going to discuss is about polar compound. We have already discussed polar bond. Now we will discuss about what? Polar compound. Polar compound. So what is polar compound? Polar compound means those compound which is having polar bond. Okay, so this type of definition is not completely 100% correct, it is partially correct. Okay, how? We will just understand the concept, then we will see. Okay, so suppose there is a compound, okay, carbon, hydrogen, here is hydrogen, here is also hydrogen, right? Now suppose this hydrogen I am going to replace with chlorine. Okay, so you know that chlorine is more electronegative than carbon, right? So here is bonding electron, here is also bonding electron, here is also bonding electron. Since carbon and hydrogen both are having same electronegativity, the bonding electron will not move. But in between carbon and chlorine is more electronegative, so bonding electron will shift towards chlorine side. As a result, what will happen? What will happen? Delta negative will develop here and delta positive will develop on carbon. And this type of bond is called as what? Polar bond. We have just now seen this, right? So this compound or molecule is having polar bond. That's why this is called as polar compound, right? Now I will give another example. So suppose same here, hydrogen, carbon, here is hydrogen, here is also hydrogen is there. Now I am going to replace these two hydrogen with chlorine, right? Now what you can see here two chlorines are there, right? So this is bonding electron, here is also bonding electron. You know that we will not discuss about carbon and hydrogen because it is clear that they are having same electronegativity. Now this chlorine will pull the electron towards itself, and this is same thing is happening over this chlorine also, and here it will develop delta negative, here it will develop delta negative, here will develop delta positive, here delta positive. Okay, two delta positive on carbon. Now if you see here two polar bond is there, CCl, this is one polar bond, CCl, this is also one other polar bond. But is that polar compound? No, it is not polar compound. Though it is having two polar bonds, but it is not polar compound. Why? The polar compound is not decided by number of polar bonds. Polar compound is decided by dipole moment. Okay, and you know that dipole moment is a vector quantity. So if you will see, if you will consider here in the first diagram, if you will see here carbon chlorine, the dipole moment is in this direction. You know this is the way to denote dipole moment. You have to draw an arrow, okay, and the arrow should be in towards negative side, and this type of thing will be there in positive side. Okay, so here there is a net dipole. Now dipole moment in molecule second, this is moving in this bond. You can create a dipole like that, and for this chlorine bond, carbon chlorine bond, you should draw dipole moment in this direction. Now you just tell me, since it is a vector quantity, one is going this direction, in another is going opposite direction, it will cancel each other and there will be no net dipole moment. Since there is no net dipole moment, this compound is not polar compound. Why not polar compound? It has polar bond, not one polar bond, two polar bond, but net dipole moment is 0. Since net dipole moment is 0, this compound is not called as polar compound. Understood? I will give one more example. Suppose H, C, H, H. Okay, I will not draw like that. I will just simply tell you like this one. Okay. Cl, 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 and here is H. Is this polar compound or no? You just think it about this. Okay. Meanwhile, I will also explain it. So if you see here, the bonding electrons will move towards chlorine. As a result, delta negative. Here also, the bonding electrons will move towards chlorine because chlorine is more electronegative, delta negative. Here also same thing, delta negative. And 3 delta positive, delta positive, delta positive. Okay. Delta positive. Too many delta positives is there. Okay. So if you draw the dipole moment for this one, okay, these all 3 polar bonds, what you can get is just see, this is one dipole moment, this is for this one dipole moment, and this is another dipole moment. Now if you see here, this dipole moment will cancel this one, these two will be cancelled because they are in opposite direction. But what about this one? This is still there. It means there is net dipole moment in this molecule. Since there is net dipole moment in this molecule is what? Polar compound. This is also what? Polar compound. So how to define polar compound? So polar compound means that compound which is having net dipole moment. Okay, so any compound which is having net dipole moment is called as what? Polar compound. Okay.